Welcome to Physics and Reality with Prof. Stuckey. I'm Emeritus Professor of Physics, Dr. Mark Stuckey, and in this video I'm going to explain how Einstein's entanglement answers a review of our previous book by Valia Allori. While I'm at it, I'll remedy Bradford Skow's confusion per his review of our previous book. This is Einstein's Entanglement, published with Oxford University Press in 2024. And this is our previous book, Beyond the Dynamical Universe, published in 2018 also with Oxford University Press. Here's where you can find Allori's entire review. I'm only going to use Einstein's entanglement to answer her question in that review and point out that her demand for dynamical explanation via causal mechanisms leads to, quote, a physics that is hideously incoherent. Here's where you can find Skow's entire review. I'm only going to respond to his confusion. Here we see that Allori wants dynamical explanation via causal mechanisms for her dynamical experiences, and Ford time-evolved stories play an important role in such constructive explanation. Philosophers of science have proposed objective accounts of explanation, but they all recognize that there's a strong sense in which explanation is, quote, explanation for us, and any account should capture our intuition that explanation is fundamentally dynamical. This is connected with causation. Intuitively, we explain an event because we find its causes. Causes happen before their effects and, quote, bring them about. And here's how Allori describes a constructive theory per Einstein in this paper. Constructive theories allow one to understand the phenomena compositionally and dynamically. Macroscopic objects are composed of microscopic particles, and the macroscopic behavior is completely specified in terms of the microscopic dynamics. By definition, constructive theories involve dynamical reductions in macroscopic objects in terms of the motion and interactions of their microscopic three-dimensional constituents. Of course, many phenomena are amenable to time-evolved constructive explanation, like the game of chess. Here you see in chess that moves must be made in a temporal order. You can't make move number 25 until moves 1 through 24 have been made. Therefore, move 25 is explained by move 24, which is explained by move 23, etc. Skow's confusion is related. It really is necessary to register how wild this idea is. I myself, at least, think that the first claim is true, dynamical explanation, but that the second, all-at-once constraint-based explanation, is certainly false. If you explain the initial state of the universe by citing a later state, you probably shouldn't explain that later state by citing the initial state. It can't be both that A because B and B because A. Actually, Brad, you can do just that. In a crossword puzzle, the words explain each other. No word has any explanatory priority over the other words. It really is the case that A because B and B because A. All-at-once game does not require specific time-evolved sequence. It's adynamical. And our use of this idea to understand physics is not idiosyncratic. In a TEDx Roma talk, Adlam points out that the laws of nature could apply all at once to the whole of history in an atemporal manner. To visualize this, think about the rules of a game of Sudoku. The rules of Sudoku don't tell you to start at the left and move towards the right. Rather, they apply all at once to the whole grid, simply judging a total solution as valid or invalid. And in principle, the laws of nature could work in a similar way, constraining all of space-time at once and choosing a whole solution in one go, rather than generating the course of history moment by moment, as in the evolution picture. In this paper, Adlam writes, for example, the solution to Einstein's equations of general relativity is not a state at a time, but an entire history of a universe, so it doesn't seem to require any conception of time evolution. A time evolution formulation of the Einstein's equations does exist, but the original global formulation remains central to research in the field, and there seems no obvious reason to think that the time evolution formulation must be more fundamental. Chen and Goldstein agree, stating, the laws of nature don't have to be dynamical. Rather, they can take the form of global constraints or boundary condition constraints for the space-time as a whole. We introduced the phrase all-at-once explanation in a 2008 paper shown here. The phrase was inspired by this garish quote. There is no dynamics within space-time itself. Nothing ever moves therein, nothing happens, nothing changes. In particular, one does not think of particles as moving through space-time or as following along their world lines. Rather, particles are just in space-time, once and for all, and the world line represents, all at once, the complete life history of the particle. Liu and Wharton use all-at-once explanation for retrocausality in this paper, where they write, by allowing both initial and final inputs into the calculation, but only permitting one meaningful result at every intermediate space-time location, the entire problem must be solved all at once, denying any objective dynamical or causal flow from one time to another. Esfield and Giesen use the idea for GRW flash ontology in this paper, where they write, GRWF theory achieves the aim of a Lorentz invariant quantum theory of matter in spacetime only if one limits oneself to considering possible entire distributions of flashes, renouncing any account of the coming into being of the actual distribution of the flashes. Against this background, we will argue that a fully relativistic ontology of GRWF is only possible if one endorses Humeanism about the laws of nature, where Humeanism in this context means laws are merely descriptive regularities or patterns in the mosaic of particular facts across spacetime, rather than metaphysically necessary governing rules. Hans, Hosenfelder, and Palmer use all-at-once explanation for superdeterminism in this paper, where they write, the settings do not cause the distribution. We prefer to use Adlam's terms, that superdeterministic / supermeasured theories apply an atemporal or all-at-once constraint, more apt and more useful. Adlam and Ravelli used all-at-once explanation for relational quantum mechanics in this paper, where they write, thus it seems that RQM is most compatible with a metaphysical picture in which the laws of nature apply atemporally to the whole of history, fixing the entire distribution of quantum events all at once. And Adlam, Hans, Hosenfelder, and Palmer created an all-at-once AAO model in their taxonomy for physics. We propose terminology to classify interpretations of quantum mechanics and models that modify or complete quantum mechanics. Our focus is on models which have previously been referred to as superdeterministic, strong or weak, retrocausal, with or without signaling, dynamical or non-dynamical, future input dependent, atemporal, and all at once, not always with the same meaning or context. So, Brad, we're not sure what it is about this all-at-once way of understanding physics that you can't understand. But let me explain our particular all-at-once principal explanation for physics and compare its consequences with those of constructive explanation when it comes to quantum entanglement. Here is how Allori describes a principal theory per Einstein. Principal theories, also called kinematic theories, are formulated in terms of principles, which are used as constraints on physically possible processes. They exclude certain processes from physically happening. In this sense, principal theories are top-down. They explain the phenomena, identifying constraints the phenomena need to obey. They are kinematic theories because the explanations they provide do not involve dynamical equations of motion, and they do not depend on the interactions the system enters into. Now let's return to Allori's review, and let me answer these questions. However, as is well known, one can dispense of causation and propose models of explanation in which laws of nature and unification of phenomena play an important role. Should I think of Silberstein, Stuckey, and McDevitt's adynamical view in this sense? Or should I connect their view with the distinction between constructive and principal theories proposed by Einstein in 1919? Should I understand SSM's view as a principal theory? But if so, what are the principles? What we provide in Einstein's entanglement is an all-at-once principal explanation of quantum entanglement from a unification of the kinematics of quantum mechanics and special relativity via the relativity principle. So, unification, yes. Principal explanation, yes. Specifically, we show how the relativity principle, aka no preferred reference frame, or the equality of all perspectives, justifies the observer independence of Planck's constant h, whence the Hilbert space kinematics of quantum mechanics. As Stern and Gerlach rotated their magnets, they saw no change in the deflection pattern of atoms. And NPRF justifies the observer independence of the speed of light c, whence the Minkowski space kinematics of special relativity. As Michelson and Morley rotated their interferometer, they saw no change in the interference pattern. Consequently, Knight could mirror his principal introduction to special relativity for a principal introduction to quantum mechanics. So, special relativity and quantum mechanics are principal theories. Accordingly, quantum entanglement is not a dynamical effect due to some non-local or superdeterministic or retrocausal mechanism. It is a kinematic fact that follows necessarily from the observer independence of h as required by the relativity principle and Planck's radiation law. This is totally analogous to special relativity, where length contraction and time dilation are not dynamical effects due to some causal mechanism like the luminiferous ether. They are kinematic facts that follow necessarily from the observer independence of c as required by the relativity principle and Maxwell's equations. If we insist on trying to create constructive explanations for Bell inequality violating correlations due to quantum entanglement per Reichenbach's common cause principle, then we are led to Maudlin's conclusion in his talk, The Great Rift in Physics, Tension Between Relativity and Quantum Theory, which you can find on YouTube. Here are his conclusions in that talk. The nub of the issue. On the one hand, relativity is understood to imply that nothing goes faster than light. On the other hand, the usual understanding of John Bell's famous theorem is that certain observed correlations between experiments done far away from each other cannot be predicted or explained if no causes go faster than light. This is what Einstein called spukhafte Fernwirkungen, or spooky actions at a distance. Basically, what Bell proved is that relativity can't be right. And we are led to believe, one way or another, God has played us a nasty trick. The voice of nature has always been faint, but in this case it speaks in riddles and mumbles as well. Quantum theory and relativity seem not to directly contradict one another, but neither can they be easily reconciled. Something has to give. Either relativity or some foundational element of our world picture must be modified. The real challenge falls to the theologians of physics, who must justify the ways of a deity who is, if not evil, at least extremely mischievous. So, if you believe a constructive explanation via Reichenbach's common cause principle is fundamental, the violation of Bell's inequality due to quantum entanglement is evidence that special relativity is wrong and in conflict with quantum mechanics because there is a preferred perspective on reality due to a deity that is evil or extremely mischievous, giving us a physics that is hideously incoherent. Alternatively, you can choose to believe Einstein's relativity principle is fundamental, in which case the violation of Bell's inequality due to quantum entanglement is evidence that there is no preferred reference frame, so the relativity principle grounds both special relativity and quantum mechanics because the deity is benevolent per strict impartiality, giving us a physics that is beautifully coherent. Which way would you bet?